Hello students, welcome to my new video. This video is all about echo. This is very special topic in physics. So students, what is echo? You know, when I am talking, my sound is deflecting from everywhere, from every reflector. But I can't hear all the reflected sounds. When the reflected sounds come after 0.1 second or more than 0.1 second, then I can hear the reflected sound separately. Then I can say the reflected sound is echo. That means all the reflected sounds are not echo. When the reflected sounds come from come after 0.1 second or more than 0.1 second, then we can say the sounds are echo. So students, we all know at 0 degree centigrade temperature, the velocity of sound is 330 meter per second. This 330 meter per second is according to your new book. Okay? At 0 degree centigrade temperature, the velocity of sound is 330 meter per second. But to hear the echo, we need a distance of 16.6 meter. What does it mean? It means that if this is a source and this is the reflector, and this is the source, between the source and the reflector, we need a distance of 16.6 meter to hear the echo. That means if the sound moves at a speed of 330 meter per second, then to hear the echo, we need a distance of minimum 16.6 meter to hear the echo. You know, when the source creates the sound moves towards the reflector, and after reflection, it will come back to the source again. Okay? That means it needs a time, and for these conditions, it will take a time of 0.1 second. And if the sound comes after 0.1 second, or if the sound comes more than after 0.1 second, then we can hear the sound or reflected the sound. We can hear the reflected sound separately, and we can say this is the echo. So students, the concept of echo is very simple. Students, sometimes you are asked to calculate the speed or calculate the velocity of sound at a certain temperature. Like they can ask what will be the speed or velocity of sound at 30 degree centigrade. As we know, at 0 degree centigrade, the speed of sound is 330 meter per second. Okay, at 0 degree centigrade temperature, the speed of sound or velocity of sound is 330 meter per second. So if they ask you what is the velocity of sound at 30 degrees centigrade, then you can use this equation. V2 divided by V1 is equal to root over T2 divided by T1. Here, students, you are going to calculate the value of V2. That means V2 is the velocity of sound at 30 degrees centigrade temperature. So you can write like this: V2 is equal to V1 multiplied by root over T2 by T1. So students, what is V1? Here V1 means 330. That means at 0 degree centigrade temperature, the velocity of sound 330, this is fixed, and root over T2 means 30 degree centigrade temperature. But we have to convert this to Kelvin. So you have to add 273 to make it Kelvin. And what is T1? T1 means 0 degree centigrade temperature. So you can't write there 0 degree centigrade. 0 degree centigrade means 273 Kelvin. So as students, you have to use the standard unit of temperature, and the standard unit of temperature is Kelvin. So you have to add 273 with the centigrade scale, and you have to convert this to Kelvin. So after doing this calculation, you can get the result. The result is the velocity of sound at 30 degrees centigrade temperature. Okay? Students, you can see here I have drawn a figure. In this figure, this is the source which is going to create a sound, and this is the reflector. and the temperature of that place is 30 degrees centigrade. So the question will be like this: for which distance between the source and reflector, for which distance between the source and reflector the source can hear the echo? Okay, so what will be the equation? So students, the equation of echo is V is equal to 2D by T. So here V means the velocity, D means the distance between the source and reflected, and we are going to calculate the value of D. So after this line we can write 2D is equal to Vt. Here V means what? V means the velocity of sound at 30 degrees centigrade temperature. To calculate the value of V, we can write V2 by V1 is equal to root over T2 by T1, the equation that we have used before. After doing this calculation, we can get the value of V2, which is V. Okay, so after this line, we can write D is equal to Vt by 2. So students, this is the ultimate equation to calculate the distance between the source and reflector, for which distance the source can hear the sound. So what will be the value of T? T means the persistence period of time. That means to hear the echo, we need a minimum distance, which is 0.1. So in the placement of T, we will use 0.1. Okay, so after doing this calculation, you can get the value of D. Students, here is another problem like the previous figure. Here I have given the distance between the source and the reflector, which is 20 meter, and the question will be like this: for this distance, will the source hear any echo or not? So the previous equation, which is V is equal to 2D. After this line, we can write T is equal to 2D divided by V. So students, here what is V? V means the velocity of sound at 30 degrees centigrade temperature, and I think that you all can calculate the velocity of sound at 30 degrees centigrade temperature that I have shown before the process. Okay, so D means what? The distance between the source and the reflector, which is 20 meter, and after putting the value you can get the time. Okay, but what will be the answer? If the sound or if the time is 0.1 second or more than 0.1 second, then you can say the source can hear the sound. So students, these kinds of or these types of mathematical problems are really very important, and these all about the echo for today's lecture, and I think you all have understood that. And thank you very much for being with me. Please subscribe my channel and press the bell button to see next videos. Thank you very much.